So today in this lecture, we will discuss the multi-level queue scheduling. In short, we call it as the MQS. And in addition, we also discuss the multi-level feedback queue scheduling, MFQS. So basically, these two kinds of scheduling are the variations from the previously discussed scheduling algorithms. So firstly, we will try to discuss the multi-level queue scheduling, MQS. So basically this multi-level queue scheduling, this is like the round robin scheduling. Only difference is that it has the multiple queues. In round robin scheduling, we have seen it involves a queue and each and every processes after processing for a certain quanta of time, they are added to the rear of the queue in round robin scheduling. So here, as we have seen in round robin scheduling or our scheduling, we have only one queue, ready queue, where the process from front of the queue will be removed and will be taken by the scheduler for processing. And after processing by the scheduler, they will be added back to the rear of the queue. That is the round robin scheduling. But here in multi-level queue scheduling MQS, it involves the multiple queues and also multiple queues for different kinds of processes. Not only kinds, but processes, as we know, will be for different purposes. So classify or categorize, OS categorize the processes into the different or separate categories. And according to these different or separate categories, the queue will be allocated to that category of process. For example, let's say 15 processes are there in memory, and we can put these 15 processes into two different groups according to two different criteria or three different criteria. So according to the different criteria, different queues will be created, and inside these queues, that particular separate category of processes will be inserted. Okay. So every kind of processes according to the category or criteria defined, they will be put inside that particular queue. And also the percentage of CPU time will be allocated to each and every kind of queue. It's not compulsory that the CPU time will be shared equally, or mainly thing is this: the CPU time can be shared at any proportion between the different queues. Later we will see it. I will be explaining some example corresponding to this. Okay. So now ready queue. So here the queue or ready queue is basically partitioned or supposed to be divided into separate queues. First one for the foreground processes, that means the interactive processes, and second one is for the background processes, that means for batch processes, with the priorities in the order. So foreground processes, as we know, they are the interactive. That means user can interact with that processes. Background are those processes which are running in background, generally the system processes. Okay. So now every queue, whatever queue we have divided, Recently, I told the ready queue is divided into the multiple queues. Okay. So every queue after dividing has its own scheduling algorithm. For example, for background processes, let's say round robin scheduling will be performed, and for background processes, FCFS, or let's say shortest job first scheduling will be performed. And there will be the fixed priority scheduling. That means, firstly, it will serve the foreground processes, then from the background processes. This is again a priority for performing the foreground process, then the background processes. But doing this thing, firstly, if the operating system is performing the foreground processes, then background processes, then obviously there will be a problem of starvation. That means all the processes in the queue, all the background processes residing in the queue will be starving for the CPU until the processes from the foreground queue. That means processes from the first queue will be processed until then that the background processes will not be processed. So obviously the background processes will be starving in this sense. So there will be possibility of starvation. Now, as I told recently, the each and every type of queue will be having certain amount of CPU time, which will be scheduled among the processes. CPU time will be scheduled among the processes. Let's say, for example, 80% CPU time will be given to the foreground processes, the foreground queue containing the round robin. Then 20% time to the background processes in FCFS. Okay, so this is 10 slides. Next, we will go for the simple example of multi-level queue schedule. Here you can see different queues are there, and according to the priority, if we say the highest priority is there, so highest priority to lower priority, we can move down. Firstly, the system processes, then interactive processes, then interactive editing processes, batch processes, and lastly, student processes. There is no certain defined categories of the processes. We can divide, or operating system divides the processes into the different separate categories according to its convenience. Okay, so category can be many, but more than one. If single category is there, so multiple queue scheduling cannot be possible, and there is no uh, meaning of multiple queue scheduling. So at least two queues will be generated from a single ready queue. And that single ready queue, which we have seen in the earlier processes, okay, will be divided into the separate different queues. Okay. So now you can read out all these points. Sorry, we have seen the uh, multi-level queue scheduling. Now it's the multi-level feedback queue scheduling. The criteria imposed on multi-level queue scheduling and some modification, and after imposing that criteria, it is called as the multi-level feedback queue scheduling. Okay, so you can read it these 4 points within a minute, then I will explain you. So first point, it says it's like the multi-level queue scheduling. Here it is written as multi-level scheduling. So I'm completing this multi-level queue scheduling. Okay, this is the thing. Multi-level queue scheduling. Except the process can move between the queues as their priority changes. That means different processes can move between the different queues as the priority of the processes will be changing. It is important point that priority of the processes will be changing. Okay. Okay. So now here they can be used for IO bound and interactive processes, the CPU priority over CPU bound process. That means IO bound process and interactive process, they will get the priority over the CPU bound processes. And in the previous lectures, we have discussed the IO bound processes. That means processes which involves a lot of input output. Interactive processes means interacting with the users or having a lot of interaction with the users. And CPU bound processes require most of the CPU time. So according to the name, processes are there. So obviously, or we can say this scheduling algorithm can be used to give the IO bound and interactive process the higher priority than the CPU bound processes. Meaning IO bound and CPU interactive process will get the highest priority so that they will execute more often than the CPU bound processes. So as I told, their priority changes. So the starvation problem in the previous scheduling algorithm can be solved. Starvation, as I told, in the foreground and background processes, where if CPU handling the foreground processes initially, then background process later on. So background process will be starving for the CPU. So here the priority of the processes is changing, and processes can move or shift the queue from one queue to another. So that means the starvation problem can be solved as the processes which are supposed to be starved for the CPU can be moved to another queue, as well as their priority can be enhanced or increased. So moving this, the process of moving, event of moving the different processes from one queue to another queue is the basically the process of the aging. Aging in the sense enhancing the priority of the processes. Okay, so this is called as the aging. Okay, so now come to MFQS parameters, multi-level feedback queue scheduling parameters. So there are some 5 or 6 parameters which will be used to define the multi-level queue feedback queue, multi-level feedback queue scheduling. So firstly, the parameters says the number of queues, first one. Second, scheduling algorithm for each queue. For each and every queue, some scheduling algorithm will be decided. And thirdly, method used to determine when to upgrade a process. There are certain methods, criteria, according to which the process will be upgraded. That means they can be moved to another queue, or aging criteria. That means some enhancement regarding their priority will be applied. So the rest of the criteria, two criteria remaining. Three I have discussed. So next one is the method used to determine when to demote a process. Some process need to be demoted and some processes need to be promoted. So there are certain methods which are used to determine when to demote that process. And lastly, method used to determine which queue a process will enter. That means again there are some methods which will decide that the processes will enter to which queue when the process needs the service. If some process wants to shift the queue from one queue to another, then to which queue the process will be shifted. Okay. So now let's move towards some algorithm, example algorithm. At random, we can discuss this algorithm. So suppose we have three queues, numbered 0, 1, and 2, with their corresponding priorities. Each and every queue will be having its own corresponding priority. Okay. So let's say, for example, some task will be executed in Q2 when the Q0 and Q1 are empty. When the process will be ready, let's say it will move to Q0. That means when that process becomes ready, it will move to Q0. Okay. Whenever the process will be running from Q number 0, provide it the uh, time quanta at the 6 millisecond. If time quanta expires, then move this process again to Q1. If process will be executed from Q1, then provide the time quanta at the 14 millisecond. If it expires, then move the process to Q2. So these are the at random some steps for the different processes which can be moved from one queue to another queue. The criteria can be decided by the operating system. Okay. So they can be any criteria. Okay. I am putting you some example regarding those kind of criteria. So again, last slide is there. If the processing is from Q2, then run a round robin scheduler within large quantum. If an interactive system, or first come scheduler if it is a batch system. So in last step, we can say preempt the queue number 2 processes when new processes will become ready. Okay, so by this we have completed the our discussion towards multi-level queue scheduling and multi-level feedback queue scheduling.